There are these things called Fourier series. In a manner of speaking, they're a way of taking a complicated whole and viewing it as a sum of its simpler parts instead. Fourier series facilitate models of natural phenomena. Ancient Greek astronomers theorized that the Earth lay at the center of the universe, with the moon, sun, and heavens rotating around it in perfect circles. However, when they looked into the night sky and observed how the moon and planets were really moving, they realized that the motion was inconsistent with their theory. Taking the moon, for example, if the moon was moving in a circle, like in the Greeks' theory, it should always be the same distance away. So why did it appear darker on some nights and brighter on others? It was also bigger on some nights and smaller on others. The Greeks had to change their hypothesis then. What if for each heavenly body there was a smaller circle rotating around a bigger circle, and the body was rotating on that smaller circle? But again, what they saw in the night sky just didn't match up. So the astronomers started adding circles on circles on circles, until they had a model of celestial motion that matched what they saw in their observations. It's known today that orbits are ellipses, not circles on circles. So how did the Greeks' incorrect theory match what they observed in the sky? The answer is Fourier series. Adding up the many circles, the parts, allowed the Greeks to model celestial motion, even without understanding the true elliptical paths. In math, orbiting around in a circle can be represented as the orbit is equal to r times e to the I omega t, where e to the it represents moving in a circle. The Greeks in their theory, though, had circles of different sizes and rotation speeds. This is where the other variables come in. The r represents radius and controls how big the circle is. The omega represents angular frequency and controls how fast the circle rotates around. Representing circles rotating on circles is simply adding up more of these terms. When we add more and more, reaching an infinite number of circles, we now have what is called the Fourier series of the orbit. Ultimately, the Greeks weren't right about how orbits worked. What they ended up doing was constructing a Fourier series approximation of the real elliptical orbits. Sure, Fourier analysis can create an ellipse approximation, but it can create really any shape too. The right arrangement of circles can make an orbit in the shape of Homer Simpson's face. Something important to note is that an orbit can be thought of as anything periodic. That is, something that repeats itself over time. So Fourier series can take anything periodic, like a waveform, and analyze it as sums of circles. From the unit circle, it's also known that circles are basically sines and cosines. Taking these two ideas together puts Fourier series in its more familiar form, as sums of sines and cosines representing waveforms. A lot of complex nature can be represented this way. The planets are not the only example. While Fourier series allowed a human civilization to model and simplify nature, it also allows nature to model and simplify nature. Your own body is performing Fourier analysis just listening to this video. Ears make Fourier series to process sound. Inside the inner ear are thousands of hair cells of varying lengths. Because the hairs are different lengths, they resonate at different frequencies. For example, long hairs will pick up waves with lower frequencies, and short hairs will pick up waves with higher frequencies. When a complex sound wave enters the ear, the hairs help the brain break it down into individual frequencies. Instead of the total sound wave then, the brain sees a bunch of simple sinusoids with different amplitudes and frequencies, and then combines them to process sounds. Rather than taking the actual sound wave as a whole, the brain is able to process the same information by analyzing individual sinusoids. Just like how the Greeks understood planetary motions as individual circles rather than actual ellipses. Behind the equations of Fourier series lies a means of representing many aspects of nature. The Greeks unintentionally used Fourier series to simplify their science. They didn't understand the true nature of orbits, but were still able to use sums of circles as a matching model. At the same time, The human body creates Fourier series naturally and subconsciously. Rather than processing the true sound wave as a whole, the brain is able to process sound using individual sinusoids. Fourier series are everywhere, and ultimately they're a tremendously powerful tool used for breaking down complicated phenomena into more understandable approximations and models.